With problem number 30, we're trying to find the period of the function y equals 1/3 sine of 1/2 x plus pi over 3. The basic structure of a trigonometric function looks like this, where a is the amplitude, b is the compression factor, and it determines the horizontal compression or stretch. C is called the phase shift, and that controls the horizontal shift or the horizontal displacement of the graph. And D would control the vertical shift. So if you notice in this particular case, we have y equals 1/3 sine of 1/2 x plus pi over 3. Now we don't quite have this in the form that's above there. We can see that D is equal to 0. There's nothing added on the outside. And we can see that A is equal to 1/3. Those are both clear. But in order to find the compression factor there, we have to factor out whatever the coefficient of x is. Inside the parentheses, x should have a coefficient of 1. So I write 1/3 sine, and then I put in brackets and factor out the 1/2. Now 1/2 times what is going to give me pi over 3? Well, 1/2 times 2 pi over 3. Half of 2 pi over 3 would be pi over 3. To complete that, and then I would be able to easily tell what the compression factor is, what the phase shift is, and obviously the vertical shift is still 0 there. So when it's written in that form, I can easily tell what my A, B, C, and D are. Now, that still doesn't give me the period. The period is still going to be the compression factor divided by the basic period of that particular trig function. Sorry, it's the basic period of that trig function divided by whatever b is. So its period is equal to 2 pi over b for sine and for cosine. For the tan and the cotangent functions, that would be pi over b. But for the sine, it's 2 pi over b, and so b is equal to 1/2. Dividing by 1/2 is the same as multiplying by 2, and so the period of that function is 4 pi. Now another way that I find helpful to look at that is when we factor out the b, that 1/2 there, what that says to me is that it says where there used to be one cycle, now there is only half of a cycle. So if in 2 pi, which is the original period of the sine function, we got one complete cycle of the graph. But now there will only be half of that, which means to get a full period, I'm going to need to double that. So instead of having a period of 2 pi, to get one complete cycle of the graph, I'm going to now need 4 pi, because only 1/2 of it is completed in the original 2 pi. So that's another way of looking at it, and that will do it for problem 30.